program. The first problem was nice. They didn't give you a set of systems, but they graphed the problems for you. They found all the corner points. They told you what was the feasible region. How do you know that? They shaded a region, and they gave you the corner points. They listened for you on the graph. Didn't even force you to read them off the graph. So they're literally asking you at this particular point to determine where in here are you going to come up with a minimum value. And it has to be at one of these 4 corner points. It will never be in the middle of the section. That's a possible solution. But if I'm a business and I want to find out the minimum amount of shipping packages somewhere, I don't want to just have any old way to plot the plane. I want to plot the plane so it's going to cost me the least amount of money. So those are just a matter of dropping them into the problem. So this would be not much of a support problem. If I look at 6x plus 4y, over here, 6 times 0 is going to be 0. 4 times 6 is going to give me a value of 24. If I look up here, 6 times 3 gives me 18. 4 times 7 gives me 28, excuse me. 18 and 28 give me, what, 46? Okay, you're frowning at me. So that means I should be doing this. I'm looking at 6 times 0, and I'm looking at 4 times 6. I'm looking at 6 times 3 and 4 times 7. I'm looking at 6 times 7, and I'm looking at 4 times 4. And I'm looking at 6 times 5, and I'm looking at 4 times 1. So which one of those values is the smallest value?
First one, 24.
The first one. So they want to know the minimum value is, and what was that, 24?
We're looking for maximum.
This one here, I'm looking for maximum first, okay, so they want maximum value. Well, you answered the question that I asked, but I didn't ask the right question. Which one of these values is the maximum value?
58.
So the maximum value is 58.
74.
And where did that maximum value come from?
74.
From a value of x being 7 and a y value being 4, so they would expect you to do something like this. And they like that answer. And then they'll promptly turn around and ask you about the other side of the coin. Well, do you have to rework the problem? No. So can you answer that question, minimum or maximum, from the same amount of work? If they change the equation, does that mean the minimum is going to occur at the same place? Or the maximum? Not necessarily. So they force you to work basically 4 simple problems where you didn't have to do a lot of work, you just had to get used to something new, the objective function. But they gave you the objective function. And after that was done, they promptly started changing things. Okay, so I'm going to go to the next problem. I know I'm not finished here, but I don't really care. But now look what happens. Oh, by the way, there's only 2 parts to this problem. And they tell you what's going to happen. What's the minimum value of P? And the second question is probably going to be, where does that minimum value occur? Look what they haven't asked you to show online. Did they ask you to graph this? No. Did they ask you to find the feasible region? No. Did they ask you to find the coordinates of all of the intercepts or all of the corner points? No. But they asked you to find the maximum value that's going to be attained from this system, and they even wrote the equation for the maximum for you. But in order for you to answer this question, you have to draw a graph, you have to plot the points, you have to find the feasible region, and all that's done behind the scenes. So a problem like this may take us 5 or 10 minutes. It just kind of depends. It's not the same problem that I'm working over here, but now that we've seen one done by hand, now it's time for us to be able to do that. So this just carries on to that same problem. Now it's time for us to do one pretty much the same. So now it's going to become followed